Precalculus, Fall 2019 ACP Preview, Problem 23. This one, a function is shown. We have f of x equals x squared minus 9 over x minus 3. Which statement best describes the continuities in the graph of f of x? Well, I hope you understand that we have a discontinuity in a function wherever our denominator is equal to 0. So we can find our discontinuities by setting our denominator, in this case x minus 3, equal to 0, or you could say not equal to, in that that's what the function cannot be, or the input value cannot be. So if we add 3 to both sides of this inequality, we have x cannot equal 3. So there is a discontinuity at x equals 3, because x cannot equal. So A, the graph has no discontinuities. That is incorrect. So really it's a matter of being able to determine what kind of discontinuity we have. In the denominator, we bring over our x minus 3, and we can rewrite our numerator, this x squared minus 9, as a difference of squares. So we take the square root of x squared, x and x, and then we have plus minus, and the square root of 9 is 3. So we have this x minus 3 in the numerator cancels the x minus 3 in the denominator, and therefore we call that a removable discontinuity, because we can remove this discontinuity algebraically. Now, as a last reinforcement of understanding, we'll go to the graphing calculator and place therein, in our function editor, we have our numerator x squared minus 9 and our denominator x minus 3. And when we graph this function, I'm going to press zoom 6 for zoom standard, we see no break, which would indicate a discontinuity at x equals 3 or anywhere else. So what that looks like in the table view is this. We see at x equals 3 we have an error, because that's where our discontinuity is. This is a point discontinuity, a whole or removable discontinuity. So that is reinforcement for our calculator. I invite the viewer to also, for understanding, look at problems 23A and 23B. I hope this is helpful. Good luck, and thanks for viewing.